Please, can you all see my screen?
Recording in progress.
Please, I'm sharing my screen. Can you see that?
Yes, please, we can see.
Okay. So the SmartPLS is a software that we normally use for primary data analysis. And I think we posted on the platform. For those of you who don't have access to the SmartPLS, you can contact Synacest, and then it's going to help you to get one for yourself. In fact, this is a very nice software for primary data analysis, and then it is very expensive. In fact, if you want to get one, it's very expensive. But I think Synacest can help you to get one at a very affordable price, and then you'll be able to, engage with us once we proceed. Otherwise, you can go to the SmartPLS software, the site, smartpls.com. Then you can get access to it, but that one, they give you only 1 month. So you can also use it for 1 month, but after 1 month, you'll not be able to have access anymore. I don't know if you understand what I mean. Yeah, so before we talk about the methods, we need to understand how research ideas become data, So this diagram that I'm showing you here, at the top, we are going to start with the abstract idea. So something that we cannot directly see or measure. Something like life satisfaction or maybe quality. It is an abstract concept you will not be able to see or hear. We just have to, indirectly measure it, how we are going to, operationalize it. So as we are going to move down, we are going to turn this idea into variables. And then we are going to have a clear measurement plan. We are going to also choose indicators as we go along. And then how we are going to set questions or how we are going to collect the data. So let's understand some of the terminologies in primary data analysis. So the first one is construct. So when you say construct is a broad or an abstract idea, a theme or phenomenon, which are which we are interested in. So it is more like a theoretical building block. And with the construct, you cannot see it or you cannot measure it directly. Okay. So for example, when you talk about intelligence, when you say somebody is intelligent, you cannot directly measure the intelligence of somebody unless we bring it down to, using variables to operationalize it, and then we understand what we mean by intelligence. Something like happiness. When you say somebody is happy, it's a broader idea because what makes somebody happy might not be the case for you. So happiness is also a broader concept or idea which we cannot see or you cannot measure directly. The same way, poverty is also a broader concept, job satisfaction, economic development, social capital, anxiety, and so on and so forth. So the key point in this slide is that construct is not something that we can measure directly. So we need to specify what it looks like in the real world. Now, going down the ladder, we have what you call variable. So variable is a specific measurable property or characteristic that we can take on different values. So what we mean here is that it varies. It can change at any point in time. Variables are the practical manifestation of constructs that we use in data collections and in analysis. So here, the link between construct and variable. A construct is what we translate into one or more variables for studies. So for example, the construct can be intelligence. The variable, we can use maybe IQ test score. We can use IQ to measure. You can also use GPA to measure the intelligence of somebody, and so on and so forth. Another example is that, for example, when you have job satisfaction, we can use maybe a score of maybe 1 to 10, okay, so that people will rate it as to how they are satisfied in their job. In another way around, you can also use maybe their intention to quit to know whether they are satisfied with their job or not. So here we are not going to use a scale. We are going to just ask them, are you satisfied with your job? Then they're going to say yes or no. Another way, we can also use the number of absentees the number of absentee days. So out of the 365 days, how many days were they absent? So this can also inform us whether they are satisfied with their job or not. So all of these three elements that we've mentioned here, we are referring to as variables. So we can use a scale of maybe 1 to 10. We can use the intention to create a number of absentee days. So you see the variables vary. And then together, this is how we will form the construct. Now let's understand what is operationalization. So here, the process of defining how you are going to measure your variable is what we call the operationalization. And this is the blueprint that connects the abstract variable, which is derived from the construct. So to concrete the steps of what the measurement, a good operationalization defines exactly what you would do and then observe. So in other words, it answers what will I do to measure this? And then what are the procedures? So let's look at the link between operationalization, construct, and then variables. So operationalization is the bridge between the variable and then the indicator. So we start from the construct, the variable, then we come back to operationalization, then we move to the indicator. So what is the meaning of indicator? In other words, we can call it measure. The indicator is the specific tool or the specific question that you ask, or maybe the observable facts you use to capture the data for a variable. So it is the outcome of what you have operationalized. An indicator often is a single item, while a measure can be a composite of several indicators. So the link here is that it is tangible. Its indicators, they are observable, they are tangible, and then it is empirical realization of your operational plan. So for example, a specific question on a survey, or maybe a reading from a lab instrument, or probably an observation from a checklist. All of these represent what you call indicator or the measure. And then let's look at example, real world example. In academic research, for example, if you want to understand what we mean by depression, depression is an abstract idea. Okay, so we need to get a variable, and a variable here can be maybe severity of depression symptoms. And this variable here, you can operationalize it as maybe you will measure severity using the patient health questionnaire. This is a standardized clinical instrument used to measure severity of depression. So in this case, participants will rate the frequency of 9 symptoms over the past 2 weeks on a scale from 0, which is not at all, and then to 3, nearly every day. Okay, so here, the indicator or the measure is the summed total score from the 9 items. Please, can you hear me? I think I got a feedback.
Please, your voice is a bit low. Can you increase your voice a little? We are struggling to hear you, please. Thank you.
Okay. Wow. Okay, so is it okay now?
I think it's okay. I think it's okay.
It's okay. Okay, very good. Okay. So a score of 10 or higher is the indicator for a clinical significant depression. And then let's look at the secure example. For example, in social science, if you want to measure poverty, as we mentioned in the example, poverty is an abstract idea. Okay, so and poverty is the state of material deprivation. We can measure the construct here. We can pick a variable as the poverty status. For example, whether the person is poor or not poor. So here the variable is poverty status. So how can we operationalize it? We can operationalize it as maybe a household is considered to be in the poverty line if its total annual income is below the federal poverty threshold. And this is set by the US Census Bureau. So it's something that is well used and known by people used to measure or operationalize poverty. So here we can say that the indicator is the household income. So any household with 4 children less than $3,000 can be seen as being within the poverty line. So another way we can also operationalize poverty here is that we can say that a household is considered to be in the poverty line if it suffers from multidimensional deprivation. So defined as lacking access to at least two of the following, that is clean water, sanitation, electricity, basic education. So if a family is at least lacking some of these assets, at least two of these, whether clean water, sanitation, electricity, we can also say that they are within the poverty line. So here, the indicator is that we are going to use a checklist to confirm the absence or presence of at least two of these clean water, sanitation, electricity, and basic education. So what we are supposed to take note here is that same construct, we can have similar variables, but different operationalization is what leads to different indicator. And then it can identify different people as what? Poor. So poor is dependent on how you are going to operationalize it. And let's look at in SmartPLS, the term variable alone is ambiguous. So you need to specify which type. Okay, if you say a variable in SmartPLS, it's very different. So we are going to call construct. In construct is also termed as latent variable. So in SmartPLS, if you don't see construct, if you don't hear construct, the other name is what you call latent variable. Okay, and normally that is the over in your model. That is the unobservable theoretical concept you are measuring. In other words, so latent or construct. And we are going to look at the two types here in SmartPLS, the reflective and then the formative. As we go on, we also have what you call the manifest variable or the indicator. And normally this yellow, we are going to look at it in the SmartPLS as we go along. So when to use PLSM and then when not to use it. This information I got it from a research paper that has been published as at 2019 by Ita. So they mentioned about 8 different statements about when to use and when not to use SmartPLS. So when your goal is to predict outcome and not maybe you want to prove a theory, in that case, it is good to use Smart or PLSM. When the structural model is complex and it includes many constructs, indicators or model relationships. So if there is multiple or complex dimensions that you want to assess. For example, we have mediators, we have moderators. It is very good to use a PLSM. So when the research objective is better understood by increasing complexity by exploring theoretical extension of established theory. So if you want to do an exploratory research, it is good to use a PLSM to, help you achieve your aim. Also, when some of the variables formed by the indicators and they are not reflected by them. For example, if you want to look at formative constructs, for example here, socioeconomic status are formed from income, education, and then occupation. These three together is what forms socioeconomic status. When your data include financial ratios or calculated indicator. So for example, maybe you are using return on assets, debt ratio, liquidity ratios from companies. So even if you're using ratios, you can use SmartPLS or PLSM to achieve your objective. Also, when you are using existing data collected by others and not data designed for your exact theory. So for example, you can use Red Bank or maybe government survey. When people are of the view that PLSM is only for primary data, but it's not always the case. You can use ratios, financial ratios, or maybe data that has already been collected, which is termed as the secondary data. And then you can use it to, analyze whatever you want to do. So it is better we know or we understand that PLSM is not only for primary data, You can also use it for secondary data. And then when to use SmartPLS, for example, when your sample size is too small. So if your sample size is too small and not too many, but at least with SmartPLS, you have to have a minimum of 30. So if your sample size is around 60, 50, you can still use SmartPLS or PLSM. Although SmartPLS or PLSM can also handle larger data sets or larger sample sizes. But even if it is too small, 30 or more, you can still use PLSM. Also, when the distribution issues are concerned, so, with every research that we do, we have assumptions. So if your data is not normal, PLSM does not really matter, does not care about normality. So even if your data is not normal, it is good to handle non-normality data. So even if your data is skewed, if there are extreme values, you can still use SmartPLS. So, SmartPLS or PLSM is very good. When research inquiries latent variable, when research requires latent variable scores for follow-up analysis, there are certain analysis that you want to do. You need the composite score or the latent score. So, for example, you can create innovation score for regression. Those of us who have some experiences in those of us who have some experience in research, if you're using something like SPSS, if you want to do regression, you have to find the composite score or the average of your variables. You can use SmartPLS alone to create your score, your composite score, or the latent variable score, and then you can use it to do your analysis in SPSS. There are other variables, the other analysis that you might also want to create latent score. For example, if you want to do what you call necessary condition analysis, SmartPLS can help you to derive your latent score, and then you can export further the score for your NC or necessary condition analysis. So let's look at the decision flow charts. When to use SEM or maybe the normal regression. So first of all, you have to set your research question. So do you have latent constructs? If the answer is yes, then you have to use SEM. I think we understand what latent is. Latent is what we call a construct, something that is not measured directly, but indirectly through indicators. If no, then you can consider using regression or multiple regression. Okay, if you have complex relationship, if you have mediation, moderation, if you have multiple dependent variable, what do you do? If the answer is yes, then you can consider SEM, structural equation model, and then use it to analyze your data. If no, then you can use the normal regression that we know. That will give us the answer. If the answer is yes, you can use SEM because SEM can handle complex model. And then if the answer is no, then you can use the normal regression. You'll be able to, analyze efficiently. So if the answer is yes, if you have at least one latent construct, then SEM is required because SEM is able to handle both measurement and then structural aspects at the same time. So now when we enter SEM, we will be resuming to the interface of the SmartPLS software very soon. But before we proceed, if you have your data, I'm going to share the data very soon to the platform so that you can do some analysis. Once you begin your analysis, there are two fundamentals model you are supposed to take notes, and that is what we call the measurements. Previously, we call it confirmatory factor analysis. Okay, so it helps us to understand how we are going to measure our constructs. And then we also have what we call the structure. It helps us to understand the relationship between the various constructs. Okay, so these two are very important. Every SmartPLS or PLSM article has these two models in the paper. You have to assess your measurement and then let us understand how the relationship exists for your study. So the first thing you're going to consider is the measurements. And the core question is that, are we measuring our construct very well? So here we are going to look at reliability. Okay, so I think we have had discussions on reliability before. In brief, the reliability is that are the indicators consistently measuring the constructs. Okay, so here we are going to use Chromebox Alpha, or what we call composite reliability. Okay, so that is reliability. In other sense, some people define reliability as if we are to collect the data today, then maybe we are using questionnaire, we've collected some data from participants and we have analyzed our results. If we are to go some other time to collect the same data from the same people, are we going to get the same results? If the answer is yes, it means that yes, there is some internal consistency with our questions or our statements that we use to measure the constructs are reliable. So we are going to use at least these two, the Chromebox Alpha, and it has to be more than 0.7. Also, the composite reliability also has to be more than 0.7. The next thing we're going to consider is validity. So are we measuring what we are thinking we are measuring? So here we have what we call convergent validity, and we are going to use average variance extracted. That is AV. So in some, we term it as AV, average variance extracted. And the score has to be greater than 0.5. If the score is not if it is not more than 0.5, it means that there is a problem with your instrument or maybe your data. So you have to work on it to achieve this threshold. Also, our outer loadings or the indicators has to be more than 0.7 at least. And if it is so, it means that if you're able to achieve Chromebox Alpha of more than 0.7, it means that your outer loadings or the score of your indicators are good. They are at least more than 0.7. Also, we are going to look at what we call discriminant validity. So the question is that with the convergent validity, it helps us to know whether the various indicators or the various statements that we have asked the participant together, are they really measuring what we intend to do? Okay, so we are going to look at practical examples in some. And then the discriminant validity, we use HTMT, heterogeneous multitude ratio, HTMT. And here, the score has to be less than 0.85. Sometimes it can be less than 0.9. I think you can also use people's studies that they've been published to justify why, for example, if your score is more than 0.85, you can justify and cite, I think you'll be good. The reviewers will not worry you that much. We also have what we call phonological criteria. We can also use phonological to assess our discriminant validity. And then we also have cross loading. We're going to look at that in the main analysis. So the last thing we are going to look at is the structural model. And the core question we are going to ask ourselves is that what are the relations between our constructs? Okay, so we are going to look at path. That is our beta or the estimate. So for example, if you're looking at how service quality translates into decision making, and you get a beta score of 0.065, it means that there is a strong positive relationship between service quality and then decision making. And then we are going to look at p-values in structural model. That is where you're going to get the significant level of our relationship. We're also going to look at R square, okay, and then adjusted R square. How much of the variance is being explained within our endogenous variable? How much of the exogenous variable is explaining the endogenous variable? We also have the effect size or the practical importance of our relationship. We're going to look at that very soon in the SmartPLS. So let me share my screen once again, and then you go straight to the SmartPLS software. So I will look at how you can go about some analysis. Also, I will share the data so that those who want to follow can also follow along. SmartPLS software, we have this nice interface. I think the reason why it is called Smart PLS, the word smart here is because it has nice interface. And then maybe it is also very intelligent. It's able to handle complex structures. So for me, I have this workspace, but if you're new, you might have to create a new workspace. So the workspace is where every analysis that you do will be saved in a folder. So for the purpose of this tutorial, so let's see how you can create a new interface. So you just go to a new workspace.
Hello, sir.
Yes, sir, boss.
Please loud down a little bit.
Oh, okay, I should slow down. Okay. Thank you very much. So now we are at the interface. I've shared
Frank,
the
he's
data
saying
on the
louder.
platform.
He's not saying slow down.
Oh, okay. Oh, I don't know why.
Or myself, I've even connected the
Okay.
headset to my PC.
Headset. Okay.
Because I was struggling to hear you.
Oh, let me see if I can use my phone. Okay, so I'll try and then be louder enough so that you can hear me. So this being your SmartPLS software, which we have already discussed that if you want some, you can contact Senior Set on the platform. He will help you to get a permanent version for yourself at a very low price. So you can change your theme if you don't want lights. You can change it, please, for those who want surfaces. But if you are new to the software, when you open, you have to create a new workspace. And as I mentioned earlier, the workspace is what saves. It's the folder that saves whatever you do, the analysis, everything that you're going to do, from importation to extraction of the data. When you have it saved within this folder for you. So you have to create. Alexander, do you have any question?
Yes, you do. So, I was asking the file you sent into the
Unless I don't think I can hear you better.
Is Frank?
Yes,
Is
sir.
Frank?
Can you hear me?
Please,
Can
I
you hear me?
suggest that we mute everybody so that they can mute themselves unless the person wants to talk before the host will unmute the person. If not, we'll have a lot of interactions, interruptions and stuff. So do the settings there so that no one can unmute themselves automatically, please.
Okay, the host will do that. But I saw Alexander's hand up. I don't know if he wanted to say something.
Can you hear
The
me?
co-host who can do that.
Okay, let me try that and see. But Alex, you can
Can
go
you hear
ahead
me,
with
Frank?
your. Yes, Alex, I can hear you talk.
Okay, so I was asking, the file you sent into the data, I saw the extension being SAV. Does it mean that you have to save the file in a particular upload? Yes.
The SAV file, it is SPSS file. The data has been converted to okay, so I think I have muted everybody. Yes. So Alex, back to your question. XPS SmartPLS is very open to importation from all different dimensional extensions of the extension files. So if your file is in SAV, which is SPSS file, you can import it. The reason why I send the SPSS file or the SAV file is that the data has been cleaned using SPSS. The data was collected online from participants, and this is how, if you can see my Excel, you can also import using Excel. But the reason why I didn't send the Excel file is that I've not cleaned this yet. Ideally, if you collect the data, you will not see the numbers here. You see 5 being strongly disagree, 4 to be agree. You see everything here in in the form of letters. And you look at the heading, you have gender, age, educational level, length of operation, the AIS. So if you, I mean, this one, you use Google Forms. So Google Forms, once you download the file, the headings will be the statement that you use to answer the question. So let's go through the questionnaire and then we see how it looks like. So this question, the questionnaire here was measuring accounting information system and then decision-making effectiveness of SMEs in Cape Coast. And then it was also looking at the remediation role of financial literacy. So it is divided into sections. We have the demographic information of respondents, and then the respondents were asked to tick. And then, so for example, this is how it was developed. But they used Google Forms, so they're not going to take, they're just going to be pressing on it. So if you are male, you just select male, female. So we are going to compare this to the response here. Once you download, so the first person said that is number 2. So the 2 here is the person is being the female, right? And then age. Age is next. So anybody who selects 1 is below 25 years. So here the person is below 25. Anybody who selects 2, the person is 25 to 29. Same applies to educational level, and then the length of operation. Now let's go to the part we are going to use SmartPLS. Ideally, this kind of, if you want to analyze demographic information, you have to use SPSS. So we can open SPSS file and see how we can analyze. So this is how it appears on my SPSS file. So this is how it looks like. If you want to do analysis with SPSS, you have to do a number of changes in here. But because we are not using SPSS, I didn't set the measurements. If you want to do analysis with SPSS, you are supposed to change this one to skills. But because we are not doing that, all the questions that we used like skills to answer them, you are supposed to change all of them to skills. And I think we have done this level of measurement from ordinal, nominal, skill. We have done this before. But this is not really important because we are not using SPSS. But what we need here is to analyze our demographics. So here, you can just go to analyze, go to descriptives, and go to frequency. So this is how it's going to look like. You can change the display to maybe variable names so that you not be confused about what you're doing. Then you select. So gender, age, education level, length of experience. So I'm able to select because when I press on the gender, I hold on to the control key on my keyboard. So gender, then I'll press on age, whilst my hand is on the control. Education, my hand is on the control. Then length of operations of business. Then I release my hand from the control. Then I'll just select this arrow. It will send them to the variable section here. So here I'm not going to do any rigorous analysis, so I'm not going to select any of these. But you can also find the quartiles. You can check the standard deviation, the variance, the range, minimum, maximum value, and so on and so forth. You can even ask SPSS to create the tables in the form of so I just want to get the table of respondents. So here, there are no missing values. The total sample size is 102. So age also 102, education 102, length of time in operation. So there's no missing value in here. Gender, 1 is male. The reason why we are seeing 1 here as the label is because we have not set all of these in SPSS. So because that's not the reason why we are here. But maybe later we are going to do that. But 1 here represents the male, because in our questionnaire, one here referred to male and then two referred to female. So same applies to what we see here. So I think they were a total of 51, 51. So it was balancing here. Let's look at the frequency. So those who have been in business, less than 1 year, they are 14. Okay, accounting for 13.7%. Those who have been in business for 1 to 3 years, they were 30. Those who have been in business for more than 10 years were number 5, so they were 21. All right. So this is going to be part of your demographic analysis. But we are looking at SEM, so we are going to not look into this. But let's look at the constructs. The constructs, the participants were asked to, select or tick, given the statement. So the constructs here, the first one was about information quality. And there were 6 indicators. So these are the indicators. And then we have labeled it as IQ1, IQ2, IQ3, IQ4, IQ5, IQ6. So this is what we have done in the SPSS file that I sent. So IQ1, IQ2, IQ3, IQ4, IQ5, IQ6. But we are comparing this to the Excel file. The Excel file has it, the AIS information, provide accurate financial information. So these are the statements here. The AIS accurate information. You see, the information from AIS is always up to date. The information from AIS is always up to date. But we cannot import this in SmartPLS because it's going to give us redundant information. So that's why we have coded the headings. And then there are no space. So we have IQ1, IQ2, IQ3. This will help us to do analysis easier with SmartPLS. So that's the reason why I sent the SPSS file. So whenever you have your data, it is always good to clean them. And we made sure that there was no mixing values. Okay, so everything was cleaned and then everything is perfect. That's why I sent the SPSS file. I don't know if Alex, you understand. So now we are going ahead. So let's look at the questionnaire. We have information quality. Oh, this is a construct. Service quality. It also has about 6 questions measuring it. We have user satisfaction. Also has 6 statements or indicators under it. We have financial literacy. It has 7 statements or indicators under it, which together measures financial literacy. We also have decision-making effectiveness. That is the dependent variable. And it has 7 statements or indicators or measures under it, together measuring the decision-making effectiveness of the respondent. Okay, so now let me set my workspace for those of you who will be new and then they want to set. So let's say I want to set my workspace to download. And I've created this folder for the purpose of what we are doing here. So I can select this folder and then I'm going to have a new, okay, so start with an empty folder. Okay, so you have to create a folder in there. Let's go back to the place. So Control-Shift-N, I'm using the shortcut. And I can call this one workspace SmartPLS 2026. So this is where my workspace is. It is under download inside the SmartPLS tutorial. So the workspace that I've created is named as Workspace SmartPLS 2026. So I'll select that folder. I'll make sure it is selected. And then I'll come down here and click on the select folder. So now this is now my workspace. So it will handle every importation, every analysis that we are going to do further. All right. So now it means that if you have not done anything yet, this is how your interface is going to be like. You have the new project, you see the PLSM is not activated because we don't have anything yet imported. So once we do that, it will activate. So we also have the CB-SEM, covariance-based SEM, but that's not our focus. We have the SCA, process regression. So the advantage of SmartPLS is that, and the reason why it is called Smart, you can do a lot of analysis. Aside the PLSM that we know, you can do covariance-based SEM, you can do GSCA process, and then normal regression that we can use SPSS to do. Okay, so now let's start a new project, and let's call it maybe SmartPLS project 1, 2026. So I'll create. Now I've created a new project within the workspace that we are working with. So what are we supposed to do? First, you can, right now we have our data already, so we can import. So let's import the data. So it's already opening where my data is. But if your data is not in downloads, you can go and look for it, whether it is in desktop, wherever it is. But mine is in my downloads, so I'll open the folder here. And then it is not within this workspace, it is in the data sample. So I'll open that. I can import the Excel file. I'll get the same. So let's try and see that. So this is my Excel. And then it has imported the headings. But you see, the headings are too many, and then it will not help you to make, it will not make your analysis easier for you. I think the reason why this red is here. Oh, shit. The reason why we have this red here is because this question was duplicated. So we have to take one away. Now, SmartPLS, this interface will give us much information about how our missing values are, whether we have missing value or not. So here, we have to take away this one. We have to deselect this one because this one is not complete. So because it has a lot of missing values. So this is not right. So you can deselect this one, and then the red will vanish. All right. So SmartPLS automatically will determine the scale for you. So all Likert scale questions are automatically metric. Unlike SPSS, which you have to go and select skill. Here, SmartPLS, we call it metric. So in SPSS, it is skill. Automatically, it has selected everything for us. All Likert scale questions are metrics. So assuming you go through and then you see something like ordinal, it is not right. You have to change it back to metric. But automatically, SmartPLS will do that for you. It also gives us information about the minimum value and then the maximum value, right? So this can also inform us whether we have an outrageous or maybe outlier within our data set. Why? Because our Likert scale was measuring 5 different Likert scale questions. So from strongly disagree to what? Agree. So meaning that one is strongly disagree, it move on to the highest number, which is strongly agree, which is 5.00. Right? So if you look through this one and then you see something like 7.0, it means that there is something wrong. It's either one of our responses or one of the respondents chose more than that. But if you look at this one, everything is 5.5. But why is this one 4? The education level, because the statements were how many? Education level. Okay, we asked them 1, 2, 3, 4. So they were supposed to choose from 4 options. That is why the maximum value is what? 4. So if you see something like 5, 6, it means that somebody has chosen more than that. Or maybe when you are doing the data cleaning, you have mistakenly inputted, or you have mistakenly input a value which is not supposed to be in it. So this is also very important. But for now, we are not going to work with this because this is not our cleaning data. But in as much as we are not going to work with this, you can still edit it and then maybe use IQ1, IQ2, IQ3, IQ4. But since we have that in the SAV file, we have to close this one. But you can still import this one and then go to OK. Let me deselect the one with the missing value. And then, let me see. This one also doubled, so let me deselect this one. So once I did this, you see the import has come. When this one was on, the import was not highlighted. That means you cannot work with importation. So you have to resolve all errors. So one thing with the SmartPLS, if there is an issue, they will highlight it for you, normally in red color. So now you can import this one. So this is it. These are the indicators. But then go back and then also import the SAV file. So right now I have one data within my workspace, which is called SmartPLS Project 1 2026. If I want to import another data, I cannot see the imports here, but what I will do is I'll right click on the data and then come back to import data file so that I can import a new data file. Then I'll import this one to give me the option to import. So you can import CSV file, TST file, SPSS file, or Microsoft Excel file. So let me import that open. So this one has also opened. So you can see that this one, there is no error because when I was doing the cleaning, I made sure that every duplicate were omitted. So here, I don't think there's any issue. Everything is in metrics as we want it. Gender is binary because gender is either male or female. That is why it is binary. So SmartPLS automatically does this for you, and then you are good to go. You can go ahead and import it because there's no missing value in here. Everything is 0000. Good. So now we have the SAV file. And SmartPLS does a lot of calculations for you. You can see your standard deviation. You can see your kurtosis, skewness, and others, the p-values of each of the indicators. You can also see the relationship between the variables. So SmartPLS automatically calculates the correlations among each of the variables, okay? So for all of them. And if you want to, report on this, you just come to copy, and then you can copy it to Excel, or you can copy it to your clipboard. When you open your Excel, so let me go to Control N. So this is a new Excel worksheet. You can just right click and paste. So to paste the correlation that we did, everything here in Excel for you. But we are not going to do that because we don't need that. Also, this interface also allows you to see the raw data, okay? So even here, if there is any missing value, you'll be able to detect it, assuming that you saw some missing value. You're able to scroll and then see that hey, this area is empty, then you can rectify that. Aside that, you can derive some indicators in here, assuming that when you were setting the questions, you set some of the questions in a reversed order. Okay, normally we do that. Those are some of the I forgot the name, the anti something. Oh, when I remember, I'll let you know. So maybe if you reverse any of the question, you can come back here and reverse them here. But what we have, there's nothing like that. There's nothing like reverse coded questions. So we are not going to use any of these. But SmartPLS gives you these options. You can reverse a skill, you can reverse a value, you can even combine some of the indicators. All right. You can transform some of the variables. You can also convert variables into dummy variables. The reverse coded name is X anti principle, yeah. So you intentionally set some of the questions in a negative manner so that it will help you to assess whether the respondents were actually reading the questions. So we call it ex ante principle. Yes. So here we don't have anything like that, so there's no need to reverse any of the skill. Also, SPSS gives you this option. So when you are doing SPSS, you're going to see how you can reverse code any of these items. So you can also add groups. You can create groups here for male and female. If you want to do moderation, if you want to do multi-group analysis, you might have to create groups for maybe males, females. You can create groups for age, the age ranges, so that you see which of the age category is doing better. Without creating them, SmartPLS also has the capability of generating them for you. So here, you can just press on it and then it can generate it for you. You can name it maybe gender group. Let me see. Okay, let's go to apply. So as you can see here, it has grouped the gender for us. So group 1, we have 51 cases. That is the number 1. All respondents who chose 1. That is group 1. So we can name it as maybe males. And then all those who chose 2, you can group it as females. Okay, so SmartPLS is able to do all of these groupings for you. Even for age, it can also do it for you. So let's see how that also works. So this is the first one I created, male and female. You can also do this group. Group 1. So group 1 are those who are less than, according to our questionnaire, group 1 are those who are below 25 years. Yes, so you can name that as below 25. Then you apply. So you can do these groupings, and this we are going to need it for multi-group analysis to see whether male and female, if you want to compare whether the male are doing better than female or the females are doing better than what the male. So this is what you call the groupings. And then if you want to clear them, you can easily delete everything. But let's leave it for now. You can also export it to Excel or CSV file for all the data that you have derived here. So now let's go ahead and create model. So we have imported our data. You have to create a new model. What model are we doing? We are doing SmartPLS, the PLS sum, partial least squares structural equation model. So we create, and then we select PLS sum here. If you are not doing PLS sum, you can select whether regression, CB sum, or process. But we are doing PLS sum. And then you have to give it a name. So maybe project 1. Project 1. So it is working. I think it will come very soon. Very good. Okay, so you see within this project, we have 2 data imported, if you can recall. So here you can see that the first one is showing the one that we imported it from the Excel. So if you want to change it, you come to this particular icon here, you select on it. And then if you can recall, the one with the SAV file, the SPSS file is what we have titled as tutorial sample. The Excel file is the one with the brackets responses. So let's select this one rather. So you can have this data here for us as easy as simple as that. Now we have the data imported. We have gender, we have age, education level. Every indicator is here. So now let's look at the interface here as well, since most of us are new to SmartPLS. If you want to go back to where you started from, this is the option. So let's go back and see. But before we can go back, we have to save it. But how did you do here that we have to save? Because we changed this one from this to that. That is why if you're going back, you have to save it. So now it is saved. So they won't ask me to save it anymore. So now I can go back ahead to that. You see now, because I saved it, the data, the sample that I saved already is already saved for me. So I don't need to even select anymore because this is what I need. Now, this is blank because you have not done anything new. Assuming we start to do something, to come back to, to come back for us to save it or not. So let's go, let's undo. So this is undo. Once you do something, you want to undo, with these two tools here will help you to undo or redo, undo or redo, undo or redo. And then you can change the canvas if you don't like this color. If you don't like this color and you want to change it, you can change it to what you like, whatever you want to do. But we are not doing this. Let me undo. Let's use the white. Then you can also change the colors. We're going to do this very soon because you cannot change. But you can change it to black and white. For example, if you are creating a model, so let's select the blue one first. We come back to the black. Aside that, we can do some convert. We can convert our data from this to maybe the time score. We can also calculate. So this is what we are going to use most to calculate or estimate our the PLS sum models. So the calculate, you can estimate your sum, you can do bootstrapping, you can do confirmatory tetra analysis, important performance map, PLS predicts. A lot of options are here, which with time we're going to go through together. And then this is the select. If you want to select anything, you want to move it around, position, and then make your model nice. You have to make your model appealing to the reviewer so that because the appearance of your model also counts. So the select option will help you to work around this. And then you also have the latent. So this is what you're going to use to create latent variables. And then once we are done, we have to connect them. Okay. We also have quadratic effects. Okay. We are going to do that with time. And then it's also going to do some indigeneity tests. I think with some of the lessons that we did earlier, our resource person took us through indigeneity, yes. And then if you want to comment, if you want to delete some of the models or something like that, you can have that option also here. So now let's see how we can create a simple model. Looking at our questionnaire, we can look at, a simple model. For example, we have financial literacy here. You might want to do a simple model saying that maybe does financial literacy predict, or is there any relation between financial literacy and then decision-making effectiveness? Okay, so here we have two constructs that we are looking at, or latent variable that we are going to look at. So financial literacy. So we coded each of the items of financial literacy as F1 all the way to F7. Same applies to decision making. We did same D1 to what? D7. So when we go back to our software, we are supposed to look for these so that we can create a model. So here's my F1. So I can just select everything by holding down the shift and then coming down the way. So already this is selected, the F1 is selected. Then I hold down the shift and come and select F7. So to select all the indicators for me, to select all the indicators for me. So now I've moved. So let me do that again. Once F1 to F7, all of these are measuring financial literacy. I'll press and hold, and then I'll move it to the blank interface. And then I'll give it a name. So financial, I already have F, so financial literacy. Then I'll press OK or enter. So automatically, it has created this first construct for me. And the name is financial literacy. All right. Now we are looking at these two models. So the first one is financial literacy. The next one is decision-making effectiveness. So I'll also come and select it. If you want to do it one by one, what you are supposed to do is that you come to the top here, press on latent. Then you come and create, or you can move it here. You can call this one decision-making effectiveness. So I've first moved the D1. So the D2 can also follow. I'll put it inside, then I'll leave it. D3, I'll select, and then whilst I'm still holding my the left mouse button, I'll come and put it back on the red, the circular, the oval. I'll leave it. Or I can do the rest together by selecting the D4, holding down the shift key, then I'll select the last D7, which is the D7 here. Then I'll move it onto my decision-making effectiveness construct. Then I'll leave it. Now, I cannot move around with this. How do you move around? You have to select, hold the left mouse button, and then move it. But why is it not moving? Because on the top here, we are on the latent. So you have to come back to select. Once you come back here, you come back to the construct again. Now you can select and move around. All right. So now let me position it here nicely. And then, so this is my dependent variable, decision-making effectiveness. And it has 7 indicators or 7 measures. So together, these 7 statements that were asked are measuring decision-making effectiveness. In the same way, let me position this one down here. And SmartPLS will also give me the option. Once I'm moving around, you see this green, it helps me to know that, oh, this is in line. So now the financial literacy and then the decision-making effectiveness are in line. So I'll leave my mouse here. And then as part of making my model beautiful, I have to move back the indicators here to the left side. So what do? You select, you make sure that you're on the select panel, the blue one. Don't forget here, the select, you come and select this one. And then once you select the construct, you realize what happens on the far right. If I click on an empty space, there's nothing on the right, but the only thing that we can see there is the canvas. Once I click on the red, you realize that the two sessions include the direction. So if you want to change the direction, I want to send it to the left. So it has come back to the left for me. And then if you want to bring it down, up to the right, you are good to go. Now I want to connect this one. I want to draw the path, or I want to establish the relationship between financial literacy and then decision-making effectiveness. So what do? I'll select from the top here. I'll come to connect. Once I come to connect, I've activated. In this case, I will not be able to move the financial literacy anymore, because if you want to move, you have to select inside. Let's see, select inside, and then you can move it around. So let me undo so that to come back to where let me undo. So it has come back to where it was. Then I'll connect on top here. I'll move to the far right. So I'll select, hold my left mouse button, what you call click and drag. So click, then you drag. Now, once you start to do that, the arrow will move. Wherever you move, the arrow will also follow. Once you reach the one that you want to connect, the construct, you leave your mouse to connect. Now the color changes from red to blue. It means that there is establishment here. So there's no issue with your data. If there is any issue, it will still be red. So now we are good to go. Now, I mentioned that we can change the colors. Maybe you are not interested in this. So I'll come to select again. I'll highlight everything here. And then maybe I can choose the black and white. So you see that there's no color in here. Probably some people might prefer to change the colors. If you also want this one, you can do it that way. So what do? You want to estimate. Let's first estimate to see what we can achieve. Now, once you come to calculate, for you to estimate, you have to select PLSM algorithm. So we select automatically, we are doing path, right? We are establishing structural model. So we have to select path instead of a factor or PCA. PCA is principal component analysis. That's what we are doing here. We are doing structural equation model. So you are supposed to select the path. And then automatically SmartPLS is going to standardize all the values for you. So that is what you have done here. If you are using SPSS will find the mean values. But SmartPLS, we use the standardized values. And then this one is always default, so you don't have to change anything here. Data, we are going to do that later. This is what we created. If you remember, this is what we created. But we are doing an estimation for the meantime. If you want to select the report, you can select it so that it will give you the report as soon as it finishes calculating. So let me unselect for now. We come back to how it works. So let's start calculating. So you press on it, automatically it will do it for you. So now you can see that this has changed. What we see here, now we have the loadings in here. So it means that the first statement is loading about 0.91, about 91% onto the construct itself, financial literacy. Same way, this is loading 0.887. So if you can recall, we established that our loadings are supposed to be more than 0.7. So as we did here, our loadings are supposed to be more than 0.7. And so what do we see here? We see 0.9, more than 0.7. Everything here is more than 0.7, so we don't have any problem. Let's look at this one. Also, everything is more than 0.7. So assuming that we have something like 0.2, it means that that person, that particular statement that was asked, there's an issue because it is not really having the threshold. The loadings are not very good. So we have to drop that. So you can select, assuming that this is 0. The first one is 0.2. You can select, right click, and then you delete. And once you do that, the newer version of SmartPLS, it automatically calculates it for you. And you can deactivate it from here on the left side, right? So once you activate it, once you do anything, it will automatically calculate for you. So let me undo, because this one, the loading is already good, so there's no need for me to deselect it, all right? So now, when we are running it, you realize that there was something like a report. Because we didn't select, that is why we have this interface. But assuming that we selected it, it would have opened this. Now let's look at the left side here. I don't know, can you see my mouse?
Yes.
Hello? Okay, very
Yeah,
good.
we can see your mouse.
Yes.
Let me also activate the one that's the spotlights. Very good. Very good. So if so we just selected open report. Now it has opened another interface for us. All right. So open report. So this is our new interface. Now let's look at the left panel. Once you go to open report, you are going to see the graphical output here. Now you can see the path. Also shown here. This value here is the path. They're showing the beta coefficient. And then the results here for the path coefficient can be given in many different forms, whether you want it in matrix, you want it in a list form, you want it in a bar chart. Okay, you can also have it. You can see the total effect you can see the outer loadings that we were seeing on the image. We realize 0.9, 0. Whatever. Now, the exciting SmartPLS is that whenever everything is good, you see it to be in green color. So here, everything here is green. So it means that we are within reach. Our threshold are on point because here we are supposed to have 0.07 or more. And because we have that, that is why everything here is in green. All right. So this is the outer loadings, which we saw here in the diagram. And then you can also see our outer width. Okay. SmartPLS has this calculation as well. It also calculates the outer width, the assign weight to them. All right. And then you can also have it in matrix in the form of list. And then you can also have latent variable scores. All right. If you can recall, we learned that SmartPLS also helps us to calculate scores that we can use for further analysis, right? So you can have the latent variable scores, and then you can export these latent variable scores for further analysis, like cluster analysis, necessary condition analysis, FSQCA analysis. There are so many analyses you can further do with this. And I also have the residuals, all right? Now, if you can also recall, the first thing you're supposed to do once you do analysis with SEM, you're supposed to do your measurement, check your measurement model. So the first thing you're supposed to check is your reliability. You want to see whether your constructs are reliable. And we mentioned that we use Chromback alpha and composite reliability, right? We did it here. So what do? You come back to the left panel once again. Once you run it, so let's start again. You come to calculate PLS sum. This time I'm selecting the open report. Then I'll just calculate it. It will open the report section for me automatically. Then I'm supposed to look at my measurements, all right? Although the graphics here gives me a prior notice about how my model is looking at, right? But I can go back to the report, check my reliability. So you go to under the quality criteria section, you will see construct reliability and validity. You press on that. It will open another panel for you. So you see we have Chromback alpha. As we mentioned, if it is above 0.7, we are good to go. Okay. And in SmartPLS, if you don't know anything about the threshold, once you see green, you are good to go. You are good to report it. So we have Chromback alpha, we have composite reliability. Composite reliability, we have it in two forms. All right. So basically, we normally report the composite reliability and then the Chromback alpha. The composite reliability, that is the row C. Okay, the row A is between the Chromback alpha and then the composite reliability row C. All right. So if you look at this score, this is 0.96. If you look at this one, if you look at the Chromback alpha, it is 0.962. The composite reliability row A is 0.962. And then the row C is 0.968. Right? So normally the row A is between the alpha and then the row C. So basically, we normally report on the Chromback alpha. This is the traditional way of reporting reliability. And then the composite reliability row C, right? Now, the difference between the alpha and then the reliability row C, the alpha is a traditional way, and normally it assumes equal weights, all right? But the composite reliability here gives accurate measurement of our construct. It does not assume equal weight. It does it differently, right? So that's the difference. So normally, if you report the alpha and then the composite reliability, that's the row C, it is enough, right? So that is the reliability. You can also have it in different form, whether if you want it in bar the chat, if you want it, yeah, so you have it in numbers or in chat, and you can also export it. All you do is that you copy to Excel or Word. So then you also learned that once you do, if your alpha and then the reliability, the competitive reliability are okay, the next thing you're supposed to check is your convergent validity. Or the next thing you're supposed to check is the validity. And we have it in two forms, the convergent validity and then the discriminant validity. So let's look at the convergent validity. So that one is also on the left here. You come to composite reliability and then validity. You come down here, or you go to the overview. It is going to be found as part of the report that you have here. So let me close this one a bit. Good. So on my far right, I have my average variance extracted. And then we have learned that it's supposed to be more than 0.5. All right. So if you check, everything here is above that. So we have 0.81, 0.823. So it's above the 0.5 threshold. So it means that each of the statements or each of the indicators, each of these questions here are measuring the intended construct. That's why on average, it explains at least more than 50% of the constructs. So the statement here are measuring at least more than 50%, and that's why we call convergent validity. So once this is achieved, you can once this is achieved, the next thing you're supposed to do is that you move to check your discriminant validity, this one. And with this one, we have three approaches. Traditionally, we use Fanelaka. Okay, we use Fanelaka criterion. So let's look at that. Now, once I've already run my model, so I'll go to report. Then under the quality criteria section, I'll come to discriminants. So let me close this one. I have discriminant what? Validity. And then with that, I have my HTMT ratio. So you can see it has turned red. It means that there is an issue with my with the relationship between the constructs. I mean, the reason why this is red is that it means that there are certain questions within financial literacy that is also, according to software, that's also measuring decision making. So that association between this financial literacy and then decision making is high. That is why it is highlighting red. So it means that there is an issue, right? So this is our HTMT ratio. We also made mention of Fanelaka. So Fanelaka here is, you can also have it in matrix form. So here, the relationship between financial literacy and decision making is 0.905. With Fanelaka, what you're supposed to look out for is that the value here is supposed to be more than the value on the left side of it. All right. How is the Fanelaka created? The Fanelaka is the square root of your AVE. So the square root of my average variance extracted. Okay. This one, when you put it on it, it will come 0.814. So the square root of that is what gives me the Fanelaka. So once, so here the square root of 0.8194 is what is giving us 0.902. So you see, it is in black because it is sometimes acceptable to have a discriminant validity of 0.9. But because we are doing Fanelaka, what we are supposed to check is that the value here on the right, the square of the financial literacy is supposed to be more than the value on the left side. So this is 0.907, this is 0.904. So because this one is bigger than that, we can say that we have met the criteria. Hope you get it. Another way we can also check for discriminant validity is cross-loading. So cross-loading, you just press on it to come. Now, if you look at this section, these indicators are D1 to D7, and they're all measuring decision-making effectiveness. All right. So D1, D2, D3, each of them are loading onto its parent. That is the decision-making effectiveness, or the construct. The values that we get, the loadings are supposed to be more than the loadings that this will give onto financial literacy. So let me take that one again. The indicators of decision-making effectiveness, that is D1 to D7, the values that it loads onto its parent construct, all right? From D1 to D7, the values that it loads onto the parent construct, or the loadings, are supposed to be more than its other construct. That is financial literacy. So if you look at D3, 0.93 is more than 0.805. D2 has 0.929. It is more than 0.802. Let's come down here. I want to run this again because of the change that has come. Good. So now the others has, now we have it D1, D2, D1 to D7. So now let's look at F1 to F7. These are the various indicators, right? And it has to load onto its parent construct. So its parent construct here is not decision making. F1 to F7 here, the parent construct is financial literacy here on top. All right. The moment I click on it, it changes that as well. All right. So the loadings of F1 to F7 on the parent has to be more than that of the other parent construct, or that of the other construct. So 0.9 here has to be more than 0.82. 0.887 has to be more than this. 0.93 has to be more than 0.839. If you do this, it means that the cross loadings are good. Now, the issue is that at least the difference between the values each indicator load on its parent, for example, F1, load on its parent, the difference between that of the loading and then the other construct is supposed to be more than 0.1. So if it is not more than 0.1, it means that there is potential discriminant validity. That is why we have our discriminant validity here, HTMT red. Okay, because the difference between the cross loadings here, for example, 0.912 and then 0.802. If the difference is not more than 0.1, one of them is what is causing the discriminant validity issue. Okay, so the cross loadings will help us to know how the difference between each of the indicators, okay, for each parent construct and then the other constructs, whether the difference is more than or less than 0.1. If it is less than 0.1, one of the construct is the one causing the discriminant validity. It means that the question that is measuring financial literacy here, for example, that question here is also measuring something within decision what making. All right. So this will also help us to remove some of the constructs so that we can achieve discriminant validity. Nonetheless, there are some studies that people publish and then they can defend it. Some say that even if it is less than 0.9, or some say if it is 0.95, you can also justify that. It all depends on the reviewer. If you want to publish, it depends on the reviewer, right? So that is it for the discriminant validity. Now, when you go to the structural model, what you're supposed to look out for is the path, the significant, the R-square, effect size. So let's go and do that. But how do you get these values? You come back to calculate, and then you run bootstrap. The bootstrap is where you can get your significant findings. All right. So you press on the bootstrap. You can change the sample size. 5,000 is okay. And then you can select most faster. This one, to run it very fast for you. It will not run certain values. For example, the HTMT, it will not run it again. So let me choose faster so that we can go faster. Everything here is okay. Two-tail is good. Significant level, we are using 0.05. Then we just calculate. Don't forget, we have already selected open report. So it will open the report for us. Now, so on the left panel, on the bootstrap section, we have the path. So financial literacy predicting decision making, the significant value is what? 0.000. So it is significant. All right. And then what else can we check here? You can also check for the R square. Okay, R square, because we ran for the slow, the faster, we can't get it here. But normally what we look out for in the bootstrap is to get our significant values, because the intercepts, the total, everything can be found in the results, the PLS algorithm that we did. So most of the times, what we look out for in the bootstrap is the significant outcome. The path, the indirect, total effect, outer loadings, everything can be found in the main PSM algorithm. Okay, so now we know how to get our bootstrap, the significant values. If you also want to know your R square can also be found in here. So the value shown here is R square. You can even change how it appears on a model. So once you run it, let's run it again. Okay, let me go back. Let me run it, and then let me deselect the open report so that it will not open the report for me. It will just leave the interface like that. So I've run it, and then I can select how this model appears. Okay, so I can close it a bit, and then the structural model, I can show what it should be. So here's the beta 0.9. I can change it and then use maybe correlation. I can use indirect effect values, so to change. So this is it. If you want to use correlation, if you want to use covariance, if you want to use F square, but ideally we always show the path coefficients, right? And then the measurements, normally people show the loadings, but you can also change it. You can show the loadings and width. You can select blank, it will just omit itself, and then you have something very clean. You can select only the width, or can select only the outer loadings, all right? And then within the construct, you can choose what it should appear, whether you want AVE. So the AVE here is what? 0.814. But if you don't explain to the reviewer, they will not know that this is the AVE. They might say that this is the R square. So basically, we normally report the R square. But if you want to get the full report on all of these, you go to the open full report, and then you go to the quality criteria, you get the R square. Oh, Alex, your hand is up. You want to ask a question? You
Yes.
can unmute and then, okay.
Oh, can you hear me?
Yes, I can hear you.
Hello? Okay, so
Yes, I can hear you.
looking at I wanted you to like repeat something for me. You said
Okay.
the bootstrap is like, is it like running like the main model for the uh That would be like the main analysis or what? I don't really understand. So we
Okay,
did
the
the
bootstrap is
reliability
where
and
we are going to
uh,
run to get our significant value. Okay, you run a bootstrap. Okay, it will use different subsamples, so you can even change it from maybe 5,000 to maybe 10,000. Okay, so bootstrap will rerun the samples. It will increase your sample size. Okay, from right now we have 102. It will rerun the samples up to 10,000 subsample sizes. Okay. Then we can choose, we chose faster so that we can get this very fast. But if you choose slower, it will run everything for you, but it's going to take a very long period of time because the sample is too huge. So now it is running. So let's see how long it takes to run 10,000 subsample size. And the faster it will be depends on your machine. So now you have run the full sample. Let's go to open report. Let's go to our path to see the significant value. It is only the bootstrap that will help us to know whether what we have run is significant or not. So that's the essence of bootstrap. But before we did the complete slower, the faster one didn't give us the R square. Okay, so because we did the slower, it is now giving us the R square, the total intercept specific. Okay, this one is specific indirect. That is when we are doing mediation. With this model, there is no mediation, so that's why we don't have anything here. But you can see our outer loadings, outer weight. Okay, you can see our AV also. But once we deactivate our amount of results, if you turn it to faster, it will not give you this option. So now it has run it, and then if you go to R square, nothing will show because we just chose faster one, and then it exempted some of the analysis. So that is it. I don't know if your question is answered, Alex.
yes, it's answered. It's answered.
Okay, thank you very much. So that is it. I don't know if anybody else also has a question. So today we have learned something about a simple model. And maybe next time you can go ahead and add other models to it. So at this point, it is 9:59. Let me leave room for people to ask their question for what you have learned today, so that we can answer them. If there is anything to do, we do it next week. Okay, so at this point, if you have any question, you can please unmute, and then you ask your question. Is there any question? Is there anything that you want to know? Is there any clarification that you need?
Yes, sir.
So, okay.
Yes, sir.
Yes, boss, please talk. I'm listening.
Sometimes we are new to the SmartPLS. So we are gradually following what you are doing, but then we will be happy if we can get the software. The software.
Oh, yes. I don't know if you're on the WhatsApp platform. If you're not on the platform, are you on the platform, please?
Yeah, I'm on the grassroots platform.
Please come again.
I'm on the ECC grassroots platform. I don't know whether you created another platform.
Oh, no, this is, okay, this platform is titled research and then publication section. So I don't know if you have the admin's contact. He can add you. I don't know who also invited you to join. Please talk to the person so that you can find your way into the platform, all right? Then you speak to the admin. Yeah, you speak to the admin. The admin will link you to how you can get the software permanently. So I'm using the permanent version. This is lifetime membership. In fact, if you have to buy this software, it is very expensive, but we can help you get it at a very good price. And not only this one, even if you want SPSS, any other software that you want, you can ask. Just go find your way through the platform, and then the admin will help you to get some of these. Please, I don't know if your question is answered.
It's answered.
Thank you very much. Please, is there any other question? Okay, so silence means consent. It means we are good and there's no question. And our time is also up. So I will end my conversation by saving my output. So next time you come back, we are going to see how we are going to resolve the issues that arrived. I mean, concerning the HTMT, we are going to also learn how we can do complex analysis, for example, moderation, mediation. Then we move forward with other analysis like PLS predicts and all of that. So
Okay,
thank you
sir.
very much for joining. Okay, so
Before